Okay, so I've had a lot of questions. We didn't quite get to enough of the web work in class. So I pulled out 3 web work problems to go over so you guys can just see some extra examples. So the first one is about composing functions together. So this is not the same as multiplication. We're going to put one thing inside the other thing, substitution, not multiplying. And this is problem 4 from the web work. So a here, f of x is the square root of x, and then minus 4 outside the root. G of x is x squared minus 5. Now, you don't have to clean these up. Like, you literally just have to put the correct thing in the correct spot with the parentheses, and that's it. So web work isn't looking for you to clean everything up and do a whole bunch of simplification. It really will just take the basic answer. All right, so when we're finding f of g of x, so let me color code these. Okay, so there's f and g. So function notation tells us f of x means to take the square root of x and then subtract 4. X is a placeholder here, though. I know we spend a lot of time before now, we've solved for x a lot, but now you have to think a little more abstractly about x. X is a placeholder for anything. So I could say f of star. Would equal the square root of star minus 4. Literally, we can put anything we want in there. All right, so for f, wherever there's an x, I'm going to put some parentheses, but otherwise I'm recopying f. Now we're going to put g inside f. So this is figuring out f of g of x, the first thing it asked. All right, so f of g of x. But g of x over here I know is the same thing as x squared minus 5. So instead of writing g of x, I'm going to write x squared minus 5. But if it helps you to see g of x in the function notation, that's fine, and then make the change. Nothing wrong with that. Okay. So those are our two functions composed together. You can write it with the parentheses there, or you could take those parentheses out, but that's all we need for f of g of x. Get a little more room here now. G of f of x. So I start with my g, things squared minus 5. And now f, I'm going to put in what f is, which is the square root of x minus 4. Now we could technically simplify this out, but I tested it and WebWork took that answer. That's all you need. No sense in going through all the multiplication there when you don't have to do it and it's not a good, you don't have to do it for a while yet. All right, so it's just about which function is going inside where. Okay. All right. Whoa. Oh, all right. Problem 13 here. This is probably one of the freakiest ones to do. Yeah, now the stylus works. Part of the freak out is there's more than one x now, so that's going to make things a little more interesting. But this whole find the inverse, it's a big skill. You need to practice it. You need to be comfortable with it because this is the mastery topic quiz. All right. So following the steps laid out by the book, our first thing is we're going to change out f of x and just write a y here. And next, we're going to solve for x. This is going to look really weird. So in order to start solving for x, I need x to not be on the bottom of this fraction anymore. So the first thing I'm going to do is clear the fractions. We did this with the systems of equations by multiplying by the common denominator, like multiplying everything by an 8. Here, what we're going to multiply by is going to look a little weirder. We're going to multiply by that ugly denominator, x minus 5. So our next line now, these x minus 5s on the right are canceling out. So we are just left with x. And then on the left-hand side, we have y times x minus 5. Okay. So let me just notate our work. Multiply by the common denominator. All right, next, we're going to get rid of parentheses, which usually means distribute. All right, so y times x and y times negative 5. So yx minus 5y, and we'll keep the x. Now here's where it gets a little more interesting. We are going to move stuff around. So get all terms with x on one side and anything else on the other. So when we're talking about moving things between sides, it's adding and subtracting. So I've got yx over here on the left, I've got an x term on the right, and I've got a negative 5y in there. So two ways we could go about this. I could get my x terms on the left side, the other stuff on the right, or if I notice the x term on the right doesn't have anything else, so if I just move the x term from the left over there, then I'll have my terms, all my x terms together. So that's what I'm going to choose to do. So minusing yx. So now we have negative 5y equals x minus yx. All right, now we did talk about this a little, but we have all the x terms on one side. So now what we're going to do is factor out the x. So because those terms both have an x and they are together on one side, so I see an x, I see an x. Now my leftovers, x times 1 will get me back to x, minus, I've got yx there, the x is out there, so I'd need the y for this to multiply back. Now we almost have x by itself. Now I have x times 1 minus y, and 1 minus y doesn't have any x's in it. So another weird step, we're going to divide by that extra thing. So here, I'm going to divide by 1 minus y, and over here, we're going to divide by 1 minus y. So negative 5y over 1 minus y equals x. All right, that is our next step on our crazy find the inverse process. Now that we got x by itself, now we're on to the swap step, and then we just change the label. So when we say swap x and y, what this really means is change every y to an x and change every x to a y. So let me just use a little highlighting here. So there's a y and there's a y. So I have negative 5 times thing over 1 minus thing equals thing. So these y's are going to become x's. And then this x is going to become a y. And then the last step is just to clean up the notation. We were finding the inverse. We have now found the inverse, so we're going to label it as such. So f inverse of x is negative 5x over 1 minus x. Now there is an equivalent answer. If we'd moved our x terms to the left, we would have ended up with positive 5x over x minus 1. Those are equivalent. I'm taking the negative from the top, distributing it through the bottom, which changes the signs, and then I'm just changing the order so it's more convenient. WebWork will take either one of these answers. We will not ask you to prove an ugly fraction like this is an inverse. It is a good algebraic skill, but it's rather tedious, and it's way too long for a test. So I'm not saying you guys can't do it. I know you guys are capable of doing it, but in the interest of saving time on the video, we're going to skip that. All right, now, number 14. So this is a function that we're going to restrict the domain and then find the inverse for that restricted domain. So this is identical to the last slide in Desmos. All right, so the first thing, the quantity x plus 7 squared. If you take a look at this, this is a normal parabola, but it's shifted over to negative 7 on the x-axis. So let me just sketch you a picture of that real quick. There we go. So not the best picture, but that is what it looks like roughly. So horizontal line test. Yeah, nope. I got 2 points if I cross it, so it is definitely not 1-to-1. So first, note that f is not 1-to-1. Yes. Of the following set selections, choose the interval on which f is 1-to-1. All right, so our vertex, our low point of the parabola is at negative 7. So the maximal domain restriction here would be everything to the left of negative 7 or everything to the right of negative 7. But anything that's a subset of those sides that's smaller but is completely on one side or the other of negative 7 would also work. But we look here, negative 11, negative 7 is between negative 11 and negative 3. Negative 9, negative 8, negative 7 is included in that one. And then from negative 5, negative 6, negative 7 is included in that one. So our only good choice here is this negative infinity to negative 7. So I'm going to mark this on the graph as well. So this is what we're finding the inverse of. So we're pretending that the pink side of the graph no longer exists. All we have is this green guy. We're going to find the inverse for that green guy. Now, What we're going to do to find the inverse is the same steps we just did, it just won't look as ugly. But because of the squared, we're going to have that weird square root situation. All right, so I'm going to go ahead and change out for the y right away. Okay. So to find the inverse of this guy, I got to get rid of that squared, and I got to get rid of that 7. The squared is further out than the 7. If I was calculating, I'd add 7 and then square it. So square is the thing I need to deal with first. So to cancel out squaring, we square root. Now, because we are choosing to apply a square root, we have to put the plus or minus on the square root. So we're square rooting both sides to start isolating x. All right, so we will have plus or minus the square root of y, and on the right, the square root and square cancel as they're supposed to, and we're left with just x plus 7. All right, now I'm adding 7 to x, so I need to cancel that out. It's the opposite. The inverse operation of adding is subtracting, so we're going to subtract 7. Like, that's what I want to put here for those two to cancel. But an equation is a balance. If I do it to one side, I must do it to the other. Exactly what I did. So I'm going to subtract 7. Now I'm putting it here in front of the plus or minus just because putting it after the square root can look a little weird, and yet Webworks still did it. So our end result here, we now have the x isolated. We have -7 plus or minus the square root of y. So this is also a sign that this function was not one-to-one, because when I try to find the inverse, I have two functions here. Plus or minus is indicating it could be the plus root or the minus root, meaning it's two things. All right, so we just need to do our swappy step. So let's recopy our function. -7 plus or minus square root equals. So this y becomes an x, and this x becomes a y. And then last step, f inverse of x equals, and I'm going to put a pin in this, and over here I'm going to say we have two options. We have -7 plus the square root of x, and we have -7 minus the square root of x. Now, how do I know which one to pick? One of the ways to know is to just get comfortable with how the graphs work. But the other way is we're going to find a point that's only on the left side. Because remember that picture I drew before, I put it on the left side of the graph. So to the left of -7 is -8. I'm going to look at my original function and figure out what f of -8 is. So -8 plus 7 squared. -8 plus 7 is -1. And -1 squared is +1. So on our left side, f of -8 maps to a +1. Okay, so on the left side of the graph, f maps -8 to -1, meaning the point -8, sorry, (1), not -1. Right. So the point -8, 1 is on f, is on the side of f we are trying to find an inverse of. So for the inverse function, I'm going to have the swap 1 comma negative 8. So we're going to take that point to our two options and see which one is actually going to map 1 to negative 8. And map just means which one is that going to work in. All right, so when I plug in 1 on this first one, negative 7 plus the square root of 1. So we get negative 7 plus 1, and we get negative 6. Whoa. Not what we wanted. Wah, wah. So not our inverse for the left side of the graph. It turns out that's the inverse for the right side of the graph. Negative 6 is a range value here. It'd be a domain in the original function. That's to the right of negative 7. So this does jive with what we know about the graph. So just to be consistent and be sure, plug in the 1. And that's negative 7 minus 1, which maps to the negative 8 that we wanted. So now our inverse function is this one. Negative 7 minus the square root of x. All right, so we practiced finding two ugly looking inverses, and we talked about function notation, substituting things in. So hopefully this helps clear up some of the confusion and gives you guys another resource to use. Okay, now I get to grade tests.